All right, good evening. So we're going to talk a little bit about starting up section 2.1 here. So this is for college algebra, and we are going to start talking about some parabolas. Okay, so here we're going to go. All right, so let's see here. We've got this. We have, this is going to be section 2.1 and graphing parabolas. All right, so what we're going to do is we are going to start, okay, with, we've got y equals ax squared plus bx plus c, and our first goal is going to be putting this into vertex form, okay? So our first goal is to put into vertex form. Now, there is another way to graph a parabola. There's using a slightly different set of techniques, and generally, if unless the instructions said put it into vertex form, if I was presented with a parabola in this way, I would probably use the other method. We're going to get to that in a couple of videos or so sit tight with that one. But the first couple of problems you have in your homework is to, well, they put it in vertex form for you. But if this was the first section, right, we would have to know how to do this. Okay? And the way we're going to do it is by a technique called complete square. All right. Now, I was looking in your book, and they gave you examples which are far harder than the ones in the homework. Okay. So in typical math teacher sort of a fashion, I'm going to do my best to scare the hell out of you with this is a really hard problem, and we're going to go through all the steps, mostly so you can see how all the steps kind of fit together. But if you're starting to lose everything on here, and maybe you're like, wow, this is kind of complicated, there's a lot of steps here, rest assured that the problems that you're going to encounter in your homework have a couple of fewer steps than the ones that we're going to show you. So if you're looking at it like, well, I never did that part, like that's because they made it a little bit easier for you. Okay, so don't feel like if you didn't complete a specific step, sometimes there's a reason why that didn't happen. Okay, so I'm going to start off by trying to relate this to something you already know how to do, okay, at least in theory. Okay? We talked about graph transformations in the last chapter, okay? And that was the idea that you can graph y equals x squared, right? That's the parent function. You know what that looks like. That's that y equals x squared looks something like this, right? Pretend that's symmetric. Now we can go ahead and, we can have a vertical transformation. Right, if I do x squared minus 1 equals y, right? It looks like x squared, but it's got a 1, right? This is a vertical shift down 1. Okay, that's all that is. So we will just go ahead and take our, right, here's our parent function, and we're just going to move it down 1 unit and graph our parabola like that. Okay. If we wanted to move it up, that would be okay too, right? If we have y is equal to, say, x squared plus 2, this is a vertical transformation. No, that isn't. This is, right? It's a vertical transformation up. Okay, so I'll say a couple of words about that. Yes, this is the first semester that you have learned about transformations. We're going to talk to you as if you have mastered them. And this book, one of the things I do like about your book is that it goes back to this transformation stuff a lot when it introduces you to a new function, a new graph. Okay, so I understand that you did not master this section this semester or the time it was given to you, but it is one of those things where I would urge you to go back and kind of relive the experience. And I'm not talking about do the most complicated ones that they have. I'm talking about, do you remember what a vertical shift is? Do you remember what a horizontal shift is? Do you remember what the negative sign on the inside, what on the outside, what a compression and expansion is? Okay, we don't need to throw in, a whole bunch of elements to do this. But at the very least, can you do a vertical and a horizontal translation? Speaking of horizontal translations, right? This is y is a equals to x minus 2 squared. Remember, this is a horizontal shift to the right. 2. I know we see the negative sign and we think left, but it's like, what does x have to be in order for this to be 0? And that's where the translation goes off to the right. Okay, so we would have our parent function, right? Y equals x squared. And then we would go ahead and move it over 2. All right. And then conversely, if we want to move it the other way, right, we'd have y is equal to, say, x plus 3 squared. X would have to be negative 3 in order for this to happen. So it's a horizontal shift to the left by 3. All right. So here we go. Again, we have our parent function. 1, 2, 3. By the way, there is no shame. Don't let anybody tell you that there's some kind of a shame if you have to do a little t-test or t-table and plot some points, because if that's where you are in order to get comfortable with this eventually, then that's where you are. Okay, so if you got to plot some points, then you got to plot some points. It's no big deal. I still remember my 5th grade teacher. She got mad at me for borrowing and carrying, right? Because when you have to do something like, like say 12 times 6 or something, right? That's 12 times 2. So you're going to have a 2 and then you carry the 1. And she would get mad at me. She's like, can't you just do that in your head? Like, I wish I could have articulated it as an adult now. It's like, look, lady, I was terrible at math in 5th grade. This was a hard problem. All right. I'm getting the right answer, doing this technique, leave it alone. Right. And I'm going to say the same thing for you. If you got to plot a couple of points, then so be it. All right. Eventually, if you're going to graduate to being able to, like, maybe at least predict what's going to happen, and that's where you are. But at the very first time you're seeing this, if you got to plot some points, then you go right ahead and plot some points. You don't apologize to anybody for that. All right. So vertex form. All right. I don't know how many times I've told that story about my 5th grade teacher. If you have heard that before from me, you realize how much I actually dislike this lady. Okay. All right, there's our vertex form. Okay, there it is. If I cover up the A for a little bit, right, this tells you we've got a horizontal shift and a vertical shift, right? The A is going to tell you compression or, a stretch. If it's negative, then it's going to have a flip to it. We're not going to worry about flips on the inside because it's symmetric. Okay, so we don't want to worry about that so much. We also don't worry about putting an A on the inside either, because that's like a horizontal compression or expansion, and we don't. It's going to look the same way if we pull the A on the outside. Okay, more or less. All right. So so that's our vertex form. This is it. We've got horizontal shift, vertical shift, and then stretch or compression vertically. And if it's a negative sign, we might have a flip. All right. So since you already know how to graph horizontal and vertical translations, being able to graph something in vertex form isn't going to be much of a stretch for you, right? We already have the skill above on the previous page. This is just adding a couple of them at the same time. Now, getting into this position, that's going to be a trick. All right. So how do you convert to vertex form? Because the homework is going to, well, in your case, the homework may not ask you for vertex form. I think it does eventually, but not the first couple of problems. All right, so how to convert to vertex form. Right. So here we go, right? Say we have y is equal to 3x squared plus 6x, and I have a minus 4 here. Okay, now I want you to keep in mind that this problem is far harder than the ones that you're going to be dealing with in your homework. Most of the time, it's either going to be in vertex form for you already, or this is putting this first coefficient and so, as something. This is simply cruel. Okay, this is just making it a lot harder for the sake of making it a lot harder. All right, it does happen, but I just want you to be aware. Like, if you have a 1 here, this first step isn't something you're going to really do. Okay, so step 1 is we're going to go ahead and put this in the correct form. Okay, we're going to put into correct form for starting complete the square. Okay, and for my students, like if your high school teacher showed you a slightly different way, like that works so much better. You know, I don't know what this guy's doing. Then go ahead and use the one that you like, because you know they're all effectively the same. It's just like, you know, how do you want to count it out? And the correct form is this first coefficient. This has to be a 1. Okay, in order to complete the square, this has to be a 1. So what we're going to do is we're going to write down 3, and then I'm going to factor. So we have x squared and then plus 2x. All right. Now, we're just going to sweep this off to the side for a moment, because it's just going to confuse things if I try to keep it in. All right. We're just going to put it off to the side. It'll come back. We'll get back to it. Okay. Now, step 2, okay, is we're actually going to start to complete complete the square here. So if you're starting off with this as a 1, then this is really going to be your step 1. But step 2 is we're going to identify the middle term, and we're going to use that to generate the number we're going to add and subtract. So step 2 is like, oh, okay, look at that. The middle term is 2. So I'm just going to write down b is equal to 2. Okay. Now this algorithm, this way of figuring this out, this is going to work every time, right, for completing a square. You find the middle term, you divide it by 2, and then we're going to go ahead and square it. Oh, we got 1. So what we're going to do here, right, this is my step 2. So we have y is equal to 3x squared plus 2x 4. And we're going to add 1 and subtract 1 inside these brackets here. Okay, so we just added 0. Okay, it's like an accounting trick at this point. Okay, we just added 0 here to kind of figure out what's going on. All right, now we've identified our middle term, and we have this, and then this is like the magic number that we're going to use to complete the square. Okay, so this is the complete the square number. So step 3 was to add and subtract. The complete square value. Okay, and you could break these steps up into like step 2, step 2a, or 2a, 2b, and 2c, whatever makes sense for you. I just came up with these steps as like, this is how I kind of think about it. But if you need to like break these down a little bit, and you need like a more precise or a more exact sort of a list of what to do, then go right ahead and do that. Make this work for you. All right. Now, what we're going to do is we're going to group these like this. Okay. We're just going to group them. So we're still going to say we have y is equal to 3. I'm going to put my parentheses up. Could you factor x squared plus 2x plus 1? You sure can. That's x plus 1 squared. Notice this b over t term is 1, and notice this is 1. This is no accident. This happens every time. Okay, that's why for my my pre-calc students, when this gets to be a lot messier, because maybe it isn't 2, maybe it's 3, and this gets really nasty because there's a lot of fractions, I want them to always have this written down so that when they go back to factor it, no matter how ugly it gets, they know it's x minus, or it's x plus this thing. Okay, so it's just always going to look like this, and that's always going to be the factorization, no matter how ugly it gets. Okay, and then we have minus 1 minus 4. Okay, now what do we do next? Well, now we have to distribute. Okay, so we're going to take this 3, right, and we're going to distribute the 3. We're going to distribute it here. This is a tricky part because sometimes, students, I see them, they get so excited that they got this that they multiply it and then they forget. So don't forget to multiply the 3 times the -1 out here. Be thorough. Okay, so this is 3. All right, we have x plus 1 squared. 3 times 1, or 3 times -1 rather, is -3. And then this -4 is just along for the ride. All right, so let's see, step 4. I should probably have just used to write this down a little bit. That we were going to distribute. All right, and then we're going to collect our terms. Okay, we're going to collect terms. Step 5, collect terms. So we have y is equal to 3x plus 1. Oh, that's a disaster. X plus 1 squared. Right? -3 minus 4, right? We're $3 in debt. We spent $4 more. Congratulations. You're now $7 in debt. Right? By the way, I do that more to make this numbers relatable. I'm not trying to insult anybody here, but I always had trouble with negative minuses. So, the way as an adult you can think about it is in debt, and that makes this a lot more accessible. So if that helps you, then again, take it. If it doesn't help you, I'm sorry, I'm going to keep saying that. Right? This looks like a lot like a vertex form problem, right? We're done. Okay, this is it. We're finished. Okay, now we get to the next part, because the first part of the book is the first part of the problem. We're going to say, put this thing into vertex form. The next thing is going to be, they're going to ask you a ton of questions about this. Like, what? What's the vertex? Well, remember, right? This is a 1 to the right, or to the left rather. Goes on height. 1 to the left, and 7 down. Okay. So my vertex, right, is -1, -7. In order to do vertex form, right? Remember, it was ax minus h squared plus k. This negative sign belongs to the formula. Okay, so this what we're looking at here, this is 3x minus -1 squared minus 7. So the x minus, that belongs to the formula, and we have -1 that we write down. We have -7. Okay, so my vertex, -1, -7. Or what do I need to make this middle part 0? -1. Okay, so that's where we have that. Now, the next question they're going to have for us is something like, what are the X-intercepts? Or, what are the X-intercepts? Okay, now this problem, easier said than done, right? X-intercepts, we got to set y equal to 0, right? So what we're going to do is we're going to solve 3x plus 1 squared minus 7 is equal to 0. Okay. Now, this is college algebra, and I know that it's a combo class with the intermediate algebra. Here's your combo part. Okay, we're going to use something called the square root principle, which means we're going to take the square root of both sides when we're ready. So we have 3x plus 1 squared, that's equal to 7, right? We just add the 7 to both sides. Then we're going to divide by 3. X plus 1 squared is equal to 7 over 3. Okay. Notice that, when you have to evaluate something, you do parentheses, exponent, multiplication, division, addition, and subtraction. We're kind of going backwards. Okay, and I should rewrite it as this way, because the multiplication and division, right? They get the same value. You just read them from left to right. Same thing with addition and subtraction. We read them from left to right. So notice how we untangled this knot. We took the addition and subtraction, dealt with that. Dealt with the multiplication, put it on the other side. Now we're going to deal with the exponent, okay? And the last thing we're going to do is the parentheses. So when you're evaluating something, we go this way. When we are solving, we end up going that way. All right, so hopefully that helps you a little bit. Like, try to remember how to untangle this knot. But here we're going to do what's called use the square root principle. Okay, so we have x plus 1 is equal to plus or minus the square root of 7/3. All right. Now, when you have a variable squared and you take the square root, you need that plus or minus, right? I'm not saying, if I just want to know, like, what's the square root of 36? It's 6. If I say, well, x squared is equal to 36, and I take the square root of both sides, then a x is equal to plus or minus 6. Because notice this is an x squared. If I put -6 in, I still get the right answer. That's the difference. It's kind of a really subtle point. So if you get it, that's great. But, if you're working on this, I don't think a lot of teachers are going to care if you put plus or minus, right? They might cross it out or maybe take off a -1 or something. But, this is not a big mistake. And if you're still sorting this out or it doesn't quite make sense, that's okay. You'll get there. All right. And now we're just going to subtract 1 because we're working inside the parentheses. Let's subtract 1, subtract 1. We get x is equal to -1 plus or minus the square root 7/3. And those are our x-intercepts, right? What is y? Well, when we first started this whole mess, we set y to be 0. Right? So our x-intercepts are -1 plus square root of 7/3, 0. And then we have -1 minus square root of 7/3, comma, 0. Okay, so these are the points, right? My x-intercepts, right, are the points, these two. All right, so I'm trying to get in the habit of writing out, these are the points when they're points, and these are the intervals when they're intervals, because I understand that the notation for this is a little bit weird. Okay, it's a little bit redundant. This one, I kind of worked it out before. This was about 0.53-ish, and this was negative 2.53-ish. Okay, so you guys can plug that into a calculator, get an approximation, because we're going to have to graph this thing, right? I'm going to want to know, like, I can't estimate that in my head. All right, let's see here. Before we get to that, we did the x-intercepts. Eventually, they're going to ask you for the y-intercept. So here, right, y had a turn at being 0. Now it's x's turn to be 0. Okay, so I want you to remember, right, we have y is equal to 3x squared. Like, this was the original thing we came out with like 20 minutes ago. Or y was equal to 3x plus 1 squared minus 7. You may use either of these equations to set x is equal to 0. They will both give you the same answer. Okay, so if I put in 0 here, because maybe I forgot this one, right, we get 3 times 1 squared minus 7. 3 times 1 is 3, minus 7 is equal to -4. If I plug in 0 here, we get 0 plus 0 minus 4 is -4. I would usually prefer to use this method, right? So my y-intercept, the point, right, is 0, -4. All right. Let's go ahead and graph it. All right. Let's go ahead and graph it. So what is my vertex? My vertex is -1, -7. Okay. Now this comes with a little bit of practice, a little bit of experience, but if you think about where your graph is going to be before you draw your axes, -1, 1, 2, 3, 4, 5, 6, 7. If you think about this and you have a thought to do your axes, like the center of the screen, as it were, around where the action is rather than always around the origin, you're going to look like a much smarter person. All right. Honestly, this does. It makes you look far more clever than you might actually be. Or you might be this clever. I don't know. And if somebody says, "Wow, that's really clever," say, "Oh, don't pass it off." You just tell them, "Yep, I am that clever." Okay, don't take away from yourself that way. All right. What was my x-intercepts? They were -2.3-ish, 2.5. So somewhere between 2 and 3 here. And the other one was about here. We had a point here. So we're going to go ahead and pretend that we go through pretend that we go through all the points here. Okay. A lot of two things. My students always complain, like, your graphs always look the same. Like, yeah, there's a reason for that. Or this looks like it was drawn by a third grader. Like, granted, okay, if you could do at least that well, I'm happy with your graph. Okay, this is a really low bar, so we know where we are. All right. They're going to ask you a whole bunch of other questions that are pretty much redundant. Okay, they're going to say, what's the axis of symmetry? I hated this question when I was a student. I hated the rest of these questions when I was a student. I get it. Because it was like, I already told you, right? Everything you need to know is sitting right here. The axis of symmetry goes to the vertex. What's the x value of the vertex? It's -1, right? So the axis of symmetry is the line x equals -1. Right? I told you the errors. I told you the vertex. We should be able to tell this. Did we have a minimum or a maximum? Like, I just drew you a picture, really? Minimum, okay? So we have a minimum, right? And we're going to put a bracket because it's a problem that we could be there, right? The minimum, is the point, right? Is -1, -7. That's my minimum, all right? So again, they'll ask us a bunch of questions. Domain, well, it's kind of a trick question. This is a polynomial. Polynomials don't have problems with their domains, all right? Polynomials are just, negative infinity to positive infinity, okay? You only have to watch out if it's a rational function or a radical, or what we're going to learn in the next section is what they call logarithmic, okay? That's the only time you have to care about that. Since it's a polynomial, it's not one of those, we don't care, it's just all the reals. I mean, unless you get some kind of a word problem where they tell you x has to be between 0 and 10. Well, then in my domain 0 and 10. Range, again, I just told you, and I told you what the minimum was. -7 off to infinity. So I always, I know the books ask for all of this, and it feels so tedious to fill all this stuff out. It feels like, are you training me to be a middle manager and fill out forms? Is that what we're really doing here? I think that's what we're doing. Okay, it's like, I just told you this information. Why do you want it 3 different times in 3 different contexts? All right, there you go. So just to be able to get through your homework, that's the kind of thing that they're going to ask us. All right, I'm going to put example 2 in another video. I'm going to be dressed the same way, so that'll it'll break this up a little bit. All right, so I will see you there.